Alright guys, so welcome to the Codechef, and we are going to solve the today's Codechef problem A and B. Okay, so this video is A problem. Most of you may have found this easy problem. It's an easy problem, but some of them might not have got the solution, so I would explain them to them. Okay, so the problem states that given an integer n, we are having from 2 to n all even numbers we are having, and we are having a we are also having a 1 value, and now we want to determine that what's the minimum number of coins we need to pay for a integer s. So let's say we are having a ss2 and ns2. So the coins we have now is 1 and 2. So the minimum number of coins to pay 2 is just 1 coin, which is 2. Now let's hit it off with the next problem, next test case. So we want to get 31, let's say, and we have 4 coins. So we will have 1, 2 and 4. So, and we want 31, correct? So how are we going to get 31 from with this number of coins? So we want what we will do is we will first divide this 31 by 4. So what's the answer? It's 7. So at least means we want a minimum number of coins, right? So we can't divide 31 by 1, so it will be like 31 coins, and we also can't divide by 2, it will be 15 coins. So what we want is the last n which we have, we will divide the number with that n such that we will get the minimum number of coins. Now if as you can see, when we divide 31 by 4, we get the minimum number of coin, which is 7, to achieve a n of 28, okay, which is 4 into 7, but we want is 31. So there are now how many coins remaining? We have 3 coins which are remaining still. So how are we going to achieve that 3 coins? So what we will do is we will traverse back again until we hit the n is equals to 1. Now if we traverse back the array, we see that 2. Now as 2 is less than 3, so we can divide 3 by 2, and we will get 3 divided by 2 as 1. That means now we also require now plus 1. We required a 2.2. We required a denomination of 2 also to achieve a sum of 31. Now again it's still not equals to 0, because we are now at 28 plus 2, which is 30. So right now we are having a sum of 30, but we want 31. So remaining is 1. So how are we going to achieve that one? It's just by taking the last one, that is the last digit. Now let's take another example. If just to clarify things off, so let's say 30 and 10. Now 4, 6, 8 and 10. Now we have this how many denomination we have? We have 6 denomination, right? So, and we want to achieve a sum of 30. Now as you can see, 30 is divisible by the last denomination, which is 10. We are not going to start from the first, we are going to start from the less, because we want a minimum number of coins. So how are we going to achieve that? We just divide the n by 10 and we get the answer as 3. That is with just 3 10 coins we will achieve the sum of 30. Okay, so in this way we will get all the minimum number of coins. Now the code for this problem is also pretty much similar only. Let's say we are having an s and we have an n. That means we want to achieve a sum of s with the n denominations starting from 1 to n, and consist of all even numbers, and it also has 1 in it and no other odd numbers. Now we start from the n while n is greater than 1 and sum is not equals to 0. We check how many coins we want. So what we do is in the last test case, as we have 1, 2, 4, so we divide 31 by 4. That means we require 7 4 coins. So as usual, we do like answer is equals to s divided by n. So now answer becomes equals to 4. Sorry, answer becomes equals to 7 because it's 31 divided by 4. Okay, now we required 7 4 coins. Now what we do is we get a copy of s, that is we store our copy equals to 31 because we also want the sum to be minus, that is 31 to be minus by means how many remaining coins. We need to find the remaining coins too, right? So we will do is 7 into 4, so which is equals to now 3. So we still want 3 to be achieved. So how are we going to achieve that 3? Okay, so what we will do is we will again run, we will check if the means if our n+2 is not equals to 0. That means if we have an odd number, that means we want a 1 in it, or means we want a single 1 as means every time. So what we will do is we will, if it is odd number, we will subtract the n by 1, we will subtract the s also by 1. Now our sum becomes equals, now here our sum becomes equals to s equals to 2, and we also increment our 1. That means now our answer becomes equals to 8. And then as we can see, our n is still equals to 2. That means it's not still it is not greater than 1. So it will loop again and we will check now. So now it will be s divided by n. So s is 2 divided by 2. As you can see, our s here, yeah, here s was 2, n was 2. So we divide 2 by 2, which is 1. So we require now what's the remaining sum? We have here we were having 8, and now we have 9. Okay, so as you can see, we got 9, and again we get the copy, which is 2. We subtract that copy with the remainder, and we get 0. And as this will not run the loop, as n is now an even number. So this loop will not if loop will not run, and as soon as we go again into the loop, we see that s is now equals to 0. So we will come out of the loop and we will print our answer, which is equals to 9. Okay, so this was the question of Codechef June cook-off, and it was also similar easy problem. It was a greedy approach. So if you like it, so make sure to hit like and subscribe, guys, because I will be uploading more contest videos. Cheers.